Chapter 2, Number 30. A 747 airliner reaches its takeoff speed of 156 miles per hour in 35.2 seconds. What is the magnitude of its average acceleration? So what we want to do is do a really quick sketch. Kind of redundant in this case, but I think it's always good to have a sketch. My airplanes are terrible, but we'll call that an airplane. And then right here is the airplane about to take off. It starts, we assume, from rest. You don't board an airliner running to the side. And then it takes off at some speed, which is 156 miles per hour. And we would like to find what is its average acceleration during that time. And we're given that the time was, we'll assume, 0 at the start, and it ends at 35.2 seconds when the plane is just about to leave the ground. So we go back to our general formulas and we say, oh wait, the definition of the average acceleration is the change in the velocity over the change in time. So here we end at 156 miles an hour. We started at 0 miles an hour. We end at 35.2 seconds, and we started at 0 seconds. And so we are left with 4.4318 miles per hour per second. So there are a couple of things that are a little weird in this. The first thing is if we're going to try and track the sig figs, and we might as well, this was really 156 miles per hour divided by 35.2 seconds, because the zeros don't really make an effect. So I have a 3-digit number on the top divided by a 3-digit number on the bottom, so I should have a 3-digit number at the end, and that would be 3 sig figs, so 4.43. And then we're left with miles per hour per second, which is a unit of acceleration, but is not particularly pretty. So the last thing is we probably want to turn it into meters per second squared to get kind of our standard units, and I'll do that in a sec. So we need to convert out the miles per hour. The first thing is maybe turn miles into meters. So that would be, there are 1.6 kilometers per mile. And do remember, you're not responsible really for knowing the conversion to imperial units from metric or vice versa. So if you needed this on a test or something, it would be given, although I'll probably shy away from using miles at all. And then we need to convert from kilometers to meters, and that's one that you actually should feel pretty comfortable doing. There are 1,000 meters for every 1 kilometer. That gets our distances into meters. Then the next thing we want to make sure we do is that we want to make sure that we get our hours into seconds. So I say, well, there is 1 hour per 60 minutes, and then there is 1 minute per 60 seconds. And then we just do some grungy calculations with our plastic pal who's fun to be with, and we get 1.96888, etc. And then we can see that if we look at our units here, miles has canceled with miles, kilometer has canceled with kilometer, meters has canceled with nothing, so meters should be where they are. But then also hours has canceled with hours, and minutes has canceled with minutes, and so I'm left with meters per second, and then we should probably take care of our sig figs. All of the conversion factors are basically defined by law, and they're therefore known exactly, so they will not change the number of sig figs available. We had 3 sig figs before, so we'll end up with 3 sig figs now, which means we round to 1.968888 to 1.97, and then meters per second is just meters per second squared. So we get that this jet airliner takes off at just under 2 meters per second squared, which is a pretty decent acceleration.